Welcome to my channel Think Max. We are dealing with NCERT Class 10 Max Chapter 1 Real Numbers. So in this session we are going to discuss about Irrational Numbers Exercise 1.3. If you like this video, just like, share and subscribe. Also hit the bell button so that you get the notification whenever I upload my videos. Also, only your support motivates me to upload the videos regularly. Thank you. Thank you for your support. Let us get into the video. So first question, we have to prove that root 5 is irrational. So usually we will take the contradiction. So already we proved root 3, root 2 are irrational. So in the same way, we are going to prove root 5 is irrational. So I am taking the contradiction, that is root 5 is a rational number. So rational number means it can be represented as fractions. So root 5 can be represented as p by q. Suppose p by q has the common factor, we can divide by the common factor, then we will get as a by b. Then a and b will be co-prime. So what do you mean by co-prime? So co-prime are numbers that are divisible by 1. That is, both the numbers common factor will be 1. Suppose I take p by q as 20 by 25. So their common divisor is 5. So I can divide by 5 on numerator and denominator. So 20 divided by 5 is 4. 25 divided by 5 is 5. So here I will say that 4 and 5 are co-prime because their common divisor is 1. So 4 can be factorized as 2 into 2 into 1. Okay. So 5 can be factorized as 5 into 1. So here their common divisor is 1. So if they have the common divisor just 1, we can say the two numbers are co-prime. So here 4 by 5 is co-prime. In the same way, we get root 5 is equal to a by b, where a and b are co-prime and b not equal to 0. Here q is also not equal to 0. Okay. So root 5 is equal to a by b. So this b, when I bring to left hand side, it comes to the numerator. So a is equal to root 5d. Okay. So squaring on both sides, we get a square equal to 5b. So a square is a product of 5. That is, a square is divisible by 5. That is, we can say 5 divides a square. So 5 divides a square. So by theorem 1.3, we know that 5 divides a. Okay. So this is one part. So if 5 divides a, then a is a multiple of 5. So we can write a is equal to 5c. So I substitute this equation, a is equal to 5c here. Okay. So a is equal to 5c is substituted here. So 5c whole square equal to 5b. So 5c whole square is 25c square, which is equal to 5b. So I divide by 5 on both sides. So 5c square equal to b. So here b is a multiple of 5. That is 5 divides, right? So here b square, right? If we squaring on both sides, right? Here is also, yeah. So a square equal to 5b square. So we squared both sides. So here a square root 5 whole square is 5. Here b square. Okay. So b square, right? So b square is a multiple of 5. So we can say that 5 divides 5 divides b square. So by theorem 1.3, we can say that 5 divides b. Okay. So already we got 5 divides a. Now we got 5 divides b. So this shows that 5 is the common factor for a and b. But we already took a and b as co-prime. That is, their common factor is only 1. But we got the common factor as 5. So this is a contradiction because we assumed that root 5 is a rational number. So our assumption is wrong. So root 5 is irrational. Okay, children, can you understand? Okay, let me write the problem. So let root 5 be rational. So we can find integers r and s such that root 5 is equal to r by s. So they have a common factor. If we divide by the common factor, we get root 5 is equal to a by b, where a and b are co-prime. Okay. So root 5 is equal to a by b. So a will be here. So this denominator is taken to the left hand side. So a is equal to root 5b. So squaring on both sides, we get a square equal to 5b square. So this means that 5 divides a square. By theorem 1.3, 5 divides a. So a is a multiple of 5. So we can write a is equal to 5c for some integer. So we are substituting this value in equation 1. We get 5c square equal to 5b square. That is 5c whole square is nothing but 25c square, which is equal to 5b square. So dividing by 5, we get 5c square equal to b square. So b square is a multiple of 5. This means that 5 divides b square. So by theorem, 5 divides b. So we got 5 divides a and 5 divides b. This means 5 is the common factor for a and b. So this is a contradiction, as we already said that a and b are co-prime. So this contradiction came as we assumed that root 5 is rational. So our assumption is wrong. So root 5 is irrational number. Okay, children. So the next problem is, we have to show that 3 plus 2 root 5 is irrational. So in the same way, we have to assume that 3 plus 2 root 5 be rational. So what we have to do, if it is a rational number, we can write in fractions. So 3 plus 2 root 5 equal to p by q. Okay. So 2 root 5 will be equal to p by q minus 3. This plus 3, when it comes to right hand side, becomes minus 3. So when I take LCM as q, this becomes p minus 3q. So what is p minus 3q divided by q? So this both p and q are co-prime. So this will be a rational number. So if p minus 3q divided by q is rational number. Also here 2 root 5. Okay. So also we can take 2 outside. So root 5 will be equal to 2 is in the numerator. So p minus 3q divided by this 2 will come to the denominator. So p minus 3q divided by 2q. So this value will be a rational number because p and q are integers. So 2 and 3 also integers. If we calculate, this value will be a rational number. So this value is equal to root 5. So root 5 will also be a rational number. But we already proved that root 5 is irrational. So our assumption is wrong. Therefore, 3 plus 2 root 5 is irrational. Okay, children? So next question. we have to prove that the following are irrational. So first one is 1 by root 2. So as usual, we will follow the same method. That is, we will assume that 1 by root 2 is rational. So if it is rational, then it will be of the form P by Q, where P and Q are co-primes. Okay, so they are co-primes. P and Q are co-primes. That is, their common factor is 1. So what happens? 1 by root 2 is equal to P by Q. So I cross multiply. Okay, so Q will be equal to P root 2. Okay, so this Q comes to the numerator and this root 2 comes to the numerator. Okay, so I keep this root 2 here. So root 2 will be equal to Q by P. So as Q and P are co-prime, this value will be a rational number. So if Q by P is rational, then it is equal to root 2. So root 2 will also be a rational number. So we already proved that root 2 is irrational. So our assumption is wrong. Therefore, 1 by root 2 is irrational. So in the previous video, I have proved that root 2 is irrational. So I have given the link in the description. If you are interested, you can check it. So next problem, 7 root 5. So in the same way, you have to assume 7 root 5 is rational. Then 7 root 5 will be equal to P by Q, where P by Q are co-prime. Okay. So root 5 will be equal to P divided by this 7 will come to the denominator, P by 7Q. So as P and Q are integers, 7 is also an integer. So this will be a rational number. Okay. So root 5 will also be a rational number. So at first we proved that root 5 is irrational. So our assumption is wrong. Therefore, 7 root 5 is irrational. Okay, children. So next to last problem, 6 plus root 2. So let us assume that 6 plus root 2 as rational number. So in the same way, if it is rational, 6 plus root 2 will be of the form P by Q. So root 2 will be equal to P by Q minus 6. Okay. So P minus 6Q by 6. As P and Q are integers, 6 is also an integer. So this value will be a rational number. So root 2 will also be rational. Then we already proved that root 2 is irrational. So our assumption is wrong. Therefore 6 plus root 2 is irrational. Okay children, can you understand? So that's all for this session. Thank you for watching. Have a nice day.